Before we start looking at what inverse functions are, let's take just a quick flashback to what inverses are in general. So when I talk about inverse operations, I mean things like addition and subtraction, or multiplication and division. Those are the inverse operations that we've talked about. We've seen that x squared and square root are inverses as we've gone through our study of math. So I like to think of inverses as my mathematical opposites. In other words, things that undo each other mathematically: addition, subtraction, multiplication, division, things like that. It's not a great definition, but it's a good working definition of what we're going to talk about. So when it comes to inverse functions, I'm going to say that the inverse function is going to be a function that undoes, I don't even know if that's a word, but undoes the original. So we start with a function. Now, the best way I can find to illustrate this is I have my original function, and it takes x's and changes them into y's. That's what f of x does. So then my inverse, whatever it is going to take those y's and change it back into x's. It just undoes what the original function does. We'll look at that in terms of some numerical examples a little further down. So when it comes to notation, I'm going to say the inverse of f of x is, and I'm going to write it like this, f with a little -1 x. And the way I read that is f inverse of x. One thing to be careful of, I know that at some point we have looked at negative powers, and you might think that that just means that I take it to the bottom of a fraction. That is not what this -1 means. He just means inverse. So don't be confused. He is not a power. It is just a notation meaning inverse. So f inverse of x. So when I'm talking inverses with the little -1, that way I know what I'm talking about. So let's look at a pretty straightforward example that I think we can just understand by thinking it through. If I look at my function f of x, for the function f, when I look at it, what he does is he takes my input and adds 4. That's what function f does to everything. Takes some sort of input x and adds 4. So if I have my inverse, and he needs to undo the original, my inverse, let me make him a different color. We'll make him purple. F inverse is going to have to undo the adds with a subtract 4. So if I want to write it out as f inverse of x, then he's going to be x minus 4. That's the inverse to my original. So if I graph them really quickly, there's f of x, get a couple points, a nice line, and try to make it hit my points a little bit better. Oh, go away. Let's try again. There we go. There's f of x. And I have my inverse at -4, same slope. So he goes up that way. That's f inverse of x. The reason I graph it is just to show you one relationship that's going to come up later. If I remember my types of symmetry, these two graphs have symmetry with respect to the line y equals x. That'll be important later. But for right now, just to get a basic idea of what an inverse function is, it undoes the original. The purple here undoes the green. When I'm looking at a chart, suppose I know that b of x has an inverse function. That's good. And that inverse function I'm going to call b inverse, using the little -1 notation. And then I have input-output charts for each of them. Now remember, The function b takes x's and creates y's. The function b inverse really takes in y's and gives me back my original x's. I know that I use x notation with b inverse, but really that's what it's doing, is taking in y's and giving me x's. So when I look at my chart, if I want to fill the rest of this out, I'm going to look for some very specific values. Here, b of x takes the number -4 and changes it into a 2, a y value of 2. So if I look over here at my chart, if I have what is going to be a y value of 2, I know he's going to end up being a -4 if I run him through b inverse. The inverse just goes backwards, takes the 2 and makes it into a -4. Let's see right here. I have a 5. I want to find out what a 5 is. So I come over and I find that right here, b inverse takes a 3 and makes it a 5, which means my original had to take the 5 and make it into a 3. Remember, b inverse is dealing with y's and x's. Lastly, if I look right here, this 1 becomes a 0. So if I come back to my b chart, 0 becomes 1. Oh, I forgot one of them. -3 becomes 5 here, an x and a y. So if I look at this y value of -5, he's going to match with that 3 right there. So it's just about remembering what's going to happen to my input and output. Am I dealing with an x or am I dealing with a y? One other question I want to pose here is, what would b of b inverse of 2 equal? B of b inverse of 2. Well, I'm going to first go to my b inverse chart and look at 2. He's right there. So really I'm just looking at what is b of -4. So then I go over to my chart of -4 on my b chart, and I notice that this is all going to end up equaling a value of 2. Now, if I look back at my original, I can start to see that I had my 2 here, and I should realize that for the functions we're going to look at, b of b inverse, because I'm doing that composition, the b and the b inverse cancel out because they are inverses, and leaves me just with the number 2. So I wouldn't have to track this the whole way through. I could just get to that answer by looking at the inverse and the original canceling out. That happens with a lot of functions, but not necessarily every function. Functions we deal with, it will, but not every function out there. If I'm thinking graphically about these inverse functions, an inverse function only exists if the graph of the function passes what we're going to call horizontal line test. So this is the test, the horizontal line test, or what I'm going to call the HLT. It's a test to see if the inverse is a function. So if you remember, there was the vertical line test, the VLT, which I used to check if a graph was a function. Now we have the horizontal line test, which will tell us if the inverse of that function or that graph is a function. So I'm going to be checking 2 things here as I go. So let me get myself a vertical line, and let me get myself a horizontal line. So if I look at the first graph, and I pick up this vertical line, try to extend him just a little bit, there we go. If I pass that vertical line across, he doesn't hit twice anywhere. So I say that this graph passes the vertical line test. So the original, what I'm going to call f of x, is a function. It passes the vertical line test. Then I go ahead and grab the horizontal line, and I pass him up just like I do that other test, just moving from the bottom up. And he never hits twice, So I'm going to say that it passes the horizontal line test. And in passing the horizontal line test, that's telling me that whatever the inverse is of this function is also a function. So vertical line test tells me if the original is a function or not. Horizontal tells me if the inverse is a function or not. So if I look at my second one, second guy passes the vertical line test. So that means that f of x is a function. And most of the things we deal with are going to be functions. If you notice, for the last two here, I'm going to go ahead and just put that f of x is a function for each, because it is. It passes the vertical line test for each of them. That's not my main focus right now. So all these are functions, but I'm going to see what I can say about f inverse here for each of them. For f inverse, I grab that horizontal line, and as soon as I start moving that horizontal line up, I notice that I hit multiple points. So what this is telling me is the inverse is not a function. If I were to find the inverse, it would not be a function, even though the original is. For the next one over, I pass that horizontal line. It never hits twice the whole way up. So that's telling me that the inverse is a function. If I were to find the inverse, it would be a function just like the original. And lastly, if I take this guy up, he very quickly hits 2 points, a lot of places, which is telling me that the inverse is not, I'm just going to write not, a function. So if I were to find it, it would not be a function. I could still find it, it's just not going to be a function like the original is. So there's a test that we can use to see if the inverse is a function, but we haven't talked about yet how do I actually find the inverse using anything in terms of graphical or algebraic means, which is what we're going to do next.